Hello and welcome to the Kuyamungi Institute, our Q&A Conversation for Exploration series. I'm Paul Robert, the Executive Director and President of the Institute, and along with my wife, Laura Lee, the Director of Research, Education, and Outreach, and of course, on behalf of our Board of Directors, our advisors, our volunteers, and supporting members, we want to thank you for joining us today. The Kuyamungi Institute is an independent, nonprofit research organization committed to researching consciousness and the human experience, following the footsteps of our founder, Dr. Felicitas Goodman. And as an educational institution, we take an open approach and invite scholars in related fields to help broaden the scope of our own work and exploration. And so that's why we call this Conversation for Exploration. And on these Sunday discussions, we've had a full spectrum of topics from neuroscience, anthropology, archaeology, ecology, philosophy, psychology, mythology, shamanism, the hero's journey, the roots of theater, art history. Did I say enough? From, like Laura said, from the arts to the sciences. You're welcome to visit our website at kuyamungiinstitute.com. All of our presentations are free, and as a nonprofit, we invite you to become a supporting member, and we want to thank you, the community members who continue to support the mission of the Kuyamungi Institute. Today, let's talk about cycles. Cycles surround us, from the weather to the economy, the sun. We look to cycles in astronomy, geology, history, and physics, and ultimately the structure of the universe itself is based on cycles. Through the study of cycles, our guest today has developed a theory of harmonics. He's suggesting that the universe could be seen as a giant musical instrument with a predictable pattern of harmonically related oscillations which determine the structure of everything, from galactic clusters to subatomic particles. From our own biological rhythms to the life cycles of consciousness itself, every aspect of our everyday existence is determined by cycles. And when we look for evidence throughout the human story, the history of the human story, the spiral is one of the most common geometric symbols we see in prehistoric art, painted and carved throughout the world. Somehow, it must be encoded in our DNA that we've always recognized this relationship between cycles of the universe and the evolution of humankind as a sacred union.
Well, I think it is encoded in our DNA that we are tied to these cycles, that they influence us in ways that we're not aware for the most part. I have a couple of favorite cycles. And one of them is this astronomical cycle that influences nature, like baby turtles who break their shells by the shore under the full moon, so it lights their way to the sea. And I wonder how the full moon affects us. I know that we have friends who have been working in the ER, emergency rooms, and they say that during the full moon, huge influx of weird accidents. I mean, they see that cycle very clearly. I've asked many. I'm also intrigued by the Milankovitch cycle, which regardless of what we do here on Earth or to our climate, will continue to lower and raise the overall amount of sunlight hitting our Earth due to these long cycles of tilt and the shape of our orbit and more. The financiers are fond of studying cycles to predict the cycles in the market. This has to be the study of us as much, right? Because we influence those decisions. In the chaos theory, I remember talking to a chaos theory researcher, and he said, what can look like a one-off phenomenon may, in fact, if you pull back and gain a larger picture, may be of a cycle so large that we don't necessarily always see the next trough, the next oscillation. But the grandest cycles are sometimes hard to see. Or these infinitesimally small cycles, these inner dynamics of the atom and its particles, these oscillations that tick away like clocks through everything, and accompanied by this background hum of the universe that we hear about. In a poetic sense, the universe is humming along, singing its song to the beat of large and tiny drums everywhere. I love that notion. So this study of cycles is quite intriguing. It's fascinating. And that's why we've invited Ray Tomes, who's the science director for the Foundation of the Study of Cycles and the director of the Cycles Research Institute, to join us from New Zealand. He's here with us today. His study of cycles has been long and deep. And since his retirement in the computer software field, he's been at it full time. He writes, "Everything in the world has cycles, oscillations, and fluctuations. The apparent solid world is an illusion, as all is in a state of flux and flow. There is no area of scientific study in which cycles have not been found. Astronomy, biology, climate, cosmology, economics, geology, history, physics, sociology, even war and weather all have cycles present in them." So Ray, welcome. So good to have you here.
Thank you.
And
Kia
thanks for-
ora from Aotearoa, which is also sometimes called New Zealand.
the indigenous word for New Zealand. I want to hear more about that. You will tell us a bit about your own story, your own quest within cycles for answers to this fascinating universe. You have a slideshow to show us, I think, of the range of cycles and some of the science that goes into it. And then we fully want to hear your harmonics theory, because yes, indeed, we are fans of the vibrational theory of the universe.
And speaking of cycles, we asked you to get out of bed very early this morning, so we appreciate you being here.
Yeah. It's what,
No
6
problem.
a.m. New Zealand time?
Now, yeah.
Yes.
So good.
Yeah. During your introduction, you reminded me of 3 or 4 more things that I could have put something about in here, and I haven't got that prepared. So yes.
Well, we'll just ask you point blank about those. But first, tell us your story. Why cycles? How did you find your way to the study of cycles?
When I was a teenager, some friends of my parents gave me a subscription to Sky and Telescope magazine as a birthday present for a number of years. And they had in them daily sunspot numbers. And I thought, I knew there was an 11-year sunspot cycle. I'd heard of that. So I started plotting these daily sunspot numbers. And after a year or two, it was very clear there was a 4-month cycle as well. And I thought, why is that? And somehow the idea occurred to me of the planets making tides in the sun. And sure enough, Jupiter and Venus are the two planets that have the biggest tidal effect on the sun. And the effect they have is comes to a peak every time they make a straight line of the sun, which is every 4 months. And not only that, the peak occurs exactly when they're lined up. So then I started to, I didn't know the correct methods for doing cycles analysis at that stage. I started writing out sunspot numbers in long rows with another row underneath. And I looked for other periods of other planetary combinations that should have an effect. And sure enough, they were there. And always the peak was when the planet and the sun lined up. So,
This was your own discovery? This was your own discovery?
It was, but then what happened is I rode my bike into the city now and then to look in the public library. And it turned out that the modern books on the sun didn't mention this. One book mentioned that in the 1800s, somebody had the same idea. But they were sure it was just a coincidence and be dismissed with time. Ha! They were wrong.
Fascinating.
NASA,
we think of the sun influencing the other planets, not so much the other planets influencing the sun. So that it's a two-way street is very interesting.
It is. And the next thing that happened was that NASA were worried about astronauts going to the moon, getting fried by big ejections from the sun. And so they began to study this, whether it was predictable. And they tried lots and lots of things. And eventually they came to the conclusion planetary alignments was the only one that worked. So NASA know this too, but people don't like to mention it because it's astrology. If you're an astronomer, you hate astrology.
Yeah, right.
Wow.
And then nothing much more happened until in my first job, which was an insurance company. They had an investments department, and the guys there looked at, there were cycles. It's clear there's cycles in the stock market and things, right? And there was a book by, what's his name? The Profit Magic of Stock Transaction Timing, Hurst. And it's a good book. He was an engineer who around the 1960s to 1970s started to write computer programs to analyze this. In those days, people hadn't used computers because they were too flipping expensive, to do this sort of work. And so that was there in the background. And then in the 70s, I began to do projections of economic conditions for businesses. And that was interesting because I wasn't specifically looking for cycles. I was looking for common movements of things by a method called factor analysis. I'll show you a slide for that. But what actually came out, a bunch of cycles jumped out at me and I thought, what's going on here? And then I started to look at cycles. So that was really where it became quite a major interest. But it wasn't until a bit later that, because I was still doing, I had the two things, I was doing system software as well as this cycles related stuff. And on a trip to the Auckland University Library, I was sitting down reading some stuff about a 160-minute cycle that some astronomers had found. It's in the sun and a lot of other things. At the moment, many astronomers deny its existence because they say it was actually a signal that's a ninth of a day. It's somehow linked to the Earth's rotation. That's absolutely known to be false. And I can show you graphs of X-ray from the sun, which show you peaks at 160-minute intervals where it goes up by 10,000%. So it's definitely not some sort of weird phenomenon. But anyway, I was reading about all this stuff in one part of the science library, and on a whim, I put that book down and I wandered a couple of aisles over, walked along, and there was a section on ancient science, and there was one book called it was particularly about ancient astronomy, and I picked it up and opened it at a random page, and it was an article about Indian astronomy, and it said there's they use this particular unit called a pada for doing the calculation of the moon's motions. And it is a ninth of a day because it divides nicely into a lot of the moon's periods, different periods have things like 0.332 or 0.554 or something, very close to a third or 5/9, very close to ninths of a day. A ninth of a day is exactly 160 minutes. So when I told this to one of my friends, he said, that's the finger of God. He's telling you this is your life's work.
That's good intuition to wander to find that. Yeah.
Later on, when you look up and tell us the name of that book, I'd love to have that. Know what that book is. That'd be very interesting.
I don't have it written down, but I know where it was in the 1980s.
Oh yeah. Okay.
So you were off and running with cycles. So then what?
We began in my company, which was a software company. My two main things were I developed system software, and I used to make applications. I could get 10 times as many computers, 10 times as many terminals running on a small computer as any other system software could. So it was very efficient. And to this day, that's being used. That was developed in around 1980. That's been used by thousands of people in New Zealand every day. They don't know that, but they've got applications written on it. So then, and then the cycles one came in, and we started an investment fund investing in futures that ran for a year. But at that time, it was just after the 87 share crash. And we were running, and I was running with a broker, one where we did very well in the test year before that. And in the year that we actually ran as a public fund, we made over 20%. And the year before that, we made about 85%. But there were some difficulties there, the government regulations and everything. It was difficulty to keep running things because they would license us one day before the end of each quarter to run for the next quarter. But if they didn't do it, we were supposed to not do any more trading, which meant our fund was illegal. And it was a really horrible situation. So I decided that the cycle stuff was so interesting. We closed the fund down, and I retired in 1989 to work full-time on cycles.
Oh, so you've been at this a long, long time.
Yeah.
Your
Well,
study
I was
of
at it for quite a
cycles.
while before. I was at it for a number of
Yeah.
years before that. Yeah.
What are the secrets of the universe you most want to decipher through cycles?
That's a good
Well, I think that I'm deciphering the secrets of the universe more through practicing Vipassana meditation. But the physical universe, this is the description. It's not just physical; it applies to other things as well. And we'll come to that later in the piece. I've got some slides that show the relationships to many what we might call Eastern ideas and
Oh,
others.
okay.
We'll link this up. Yeah.
Yeah, I want to follow up on that though, because it's interesting that you're having a foot in both worlds, both as a scientist and doing the research and the analysis, but you're also using the field of meditation as an opportunity
Yeah.
for you to explore the discovery even further.
Yeah, yes, I definitely, I've always thought of it as having one foot in each camp.
Yeah.
And there's not a lot of people like that. When I put stuff first on the internet, it was about physics, cosmology, geology, and other things. And I started getting emails from people in the alternative health field, and I thought,
Yeah.
what's happening here? And and they were seeing the stuff that I didn't know about yet that year. But an Australian friend, Pete Brown, I went over to visit him, and he told me, you've got to apply it to life. I said, no, life's too complicated. I'm only trying to work out the formula for the universe. But we did apply it to life, and yeah, it had some interesting things came out. Yeah.
I bet.
And we're going to hear about these.
That's could be.
You have a
Yeah, yeah.
slideshow. Do you want to say anything to put it into context, what you're going to show us?
No, I've tried to put some stuff in order to have some sort of flow to it, but then I found a lot more stuff that's just I've stuck on the end. So we probably won't have time for all that, but it doesn't matter. But I may need to refer to it to show you a couple of things. So
Yeah,
yeah,
sure.
let's
Yeah.
go with the slideshow. Yeah.
Okay.
Yep.
Great.
Okay, Ray, we
Okay, Ray.
see your slides.
So that's me, and there's a couple of links there. You can go back to this on the video if you want to find those things. For a long time, I ran a blog called Wobbly Universe because it's all about the whole universe's oscillations and nothing but that, which you people are very familiar with. When I say that to physicists, they say, well, there are waves and stuff, but one of the things that the physicists try to do is they try to calculate the universe from the bottom up. They try to start from the tiniest particles. That's why they're trying to find these smaller and smaller things with the accelerators. The universe doesn't work like that. It works from the top down. So we start from the larger scale. And I can show quite clearly that that works much better going downwards from the larger scale to the smaller.
No, I like that. Yeah, look at the big picture.
This was my analysis 1977 or thereabouts, might have been 78 because I see the graph go to 77 of the New Zealand economy. At this stage, I knew a bit about how to use this program, fractal analysis, and I fed it lots of different things and analyzed it. And it's looking for common factors. So you're trying to find what things tend to move together, which can give you some insights. And you can see, and it's coming up with 9 factors. The lower number, the more powerful that one is in explaining what's going on. And you can see there's one there's a big, slow one, factor number 1. And then I'll mention factors 3 and 4, which are both about 4 years, and factor 6, which is about 3 years. Now, at that stage, New Zealand has elections every 3 years. And of course, America has every 4 years, and it influences a lot of the rest of the world. So at this stage, I thought, that's America and that's New Zealand. And there's some other ones there. There's a 7-year one that rates agriculture. So then I said, okay, let's actually look for the cycles now that there seem to be some there. And I didn't know properly how to do a cycles analysis at that stage, but I worked out a method that worked. And then I discovered you're supposed to do frequency, not period. But that doesn't matter, it works. And so I gradually varied a cycle period from 4 to about 11 or 12 years. And I found out how strong were cycles present in all my data. And you can see there's very strong peak at 4.45 years, 5.9 years, 7.15 years, and a bit of a peak at 9, but it's a bit spread out, hard to say exactly where. Now, I see the 4 arrows I put up there. I added those later. And it turns out if we multiply 9 years by 4, 7.15 by 5, 5.9 by 6, and 4.45 by 8, they all come to close to 35.6 years. I thought, what's so special about that? And then I did some analysis of wheat prices weekly wheat prices. This was annual data, so you couldn't go to smaller cycles in much more than less than 3 years. And it was clear from those. I got a whole bunch of cycles out, and the relationships of them all were like the white notes on the piano plus 2 black notes, E flat and B flat. And not everyone was there, but it's as if somebody sat on the keyboard of the piano and then you slowed it down by 1,000,000 times. Then I realized 4, 5, 6, 8, that's a major chord in music. So what this is this a major chord in the New Zealand economy?
Interesting. Oh,
Seeing the harmonics relationship.
the universe is singing a song every
Yeah. So at that stage, I had this idea that the moon, the position of the moon affected atmospheric tides, and the planets affected the sun. I developed another theory on that. There's at least 4 theories about how the planets affect the sun. And then there's all the stuff going on the sun, which affects the Earth, temperature, magnetic field, all of the stuff, which affects the economy and all of that. So I had this idea of this flow of effects. And what I was working towards was the first statement of the harmonics theory, which is that when you go from one thing to another, like the sun has an 11-year cycle, but when we look at the wheat prices, it has a 5.5-year cycle, exactly half. And so my realization was, if we have a cycle going on in temperature or rainfall or something of 11 years, but we're growing wheat in a place that's optimal, then over the 11 years, I'm trying to do this here. Can people see me
like
as well?
a bell curve. A bell curve.
We've got some sort of a curve where over the 11-year cycle, we'll come to the optimum condition, then back down again, and then back up and then back down again. So we'll get a 5.5-year cycle in how good the conditions are. And that explains why we get this wheat cycle, half of the other one. And so in this process of all of these steps, no matter what the relationship is between things, in that case, I had a little parabola sort of thing, no matter what the relationship is, when you have one thing affecting another, and there's a cycle in the one thing, it will produce harmonics of that cycle in the other one, which are exact frequency multiples. Now that's well known in physics, that you do, if you pluck a guitar or anything like that, that you get harmonics of the thing. Nothing unusual there. What I did was added one extra thing to that. But this is showing, when I got to the foundation for the study of cycles, Edward Dewey had this table at the bottom. He started from 17.75 years, and he multiplied by 2 going up to the left, divided by 2 going down to the right, multiplied by 3 going up to the right, and divided by 2 going down to the left, right? And then you can combine them. Divide by 2, divide by 3 gives you 2.96, with all 3 and 2 does the same thing, and so on. And then we start comparing this to what I had, 4.44 years. I had 4.45. 5.92, I had 5.9. 7.1 doesn't fit that, because that's a fifth of the thing, and the others are 4, 6, and 8, which are proportions of 2 and 3. My approximate 9 years is 8.88. He's got 35.5 years compared to my 35.6 multiple. So it's clear Dewey was using different data from different countries in a different time period to me, and he'd found exactly the same pattern. Well, essentially the same pattern, right?
Yes.
So you have to explain who Dewey is, by the way.
So Edward Dewey, people always ask me, is he the guy that did the Dewey Decimal System? No, he's not. He's very interesting in his own right. He came out of university about early 1930s, and he had very fantastic record of doing stuff there. And he was employed by the United States government, and the president at the time assigned him a job to say, why did this 1929 crash occur? So he thought, I'd better ask other people too. So he went and asked 100 economists why, and he got 100 different answers. And so he said, there's only one of them I believe. He's the one that said, Dewey, we really don't know. And then someone else told him, don't look at why things happen, look at what happens. And he decided that's actually good advice. And he began to look at what was happening, and he found there were cycles that he could follow through the 1920s. And when he ran them forwards, they predicted all the cycles were down in the same phase together when the crash occurred, and it did predict the crash. Incidentally, before I heard of Dewey, in 1985, 86, I was doing the same thing, running cycles forward, and it predicted a crash in 1987. I predicted September. It actually happened in October, just like that one in 1929 did. And then when I got to the Cycles Foundation and I found Dewey's cycles, he died in 1979. His cycles published in 1967 for the stock market. I ran them forward and they predicted the crash in 1987 as well. So that's how accurate he got the cycles. It's clear that these things are predictable, at least to some extent. This is
ask you about today, but that's a different conversation.
This is a graph I made of all of the cycles ranging from 4 months to 64 years. It's hand drawn, as you can see. I put one dot there for every cycle that was listed in the cycles catalogue by its cycles period. And as you can see, there's some like 4 months and 8 months, 2 years, 3.4 years, nearly 6 years, and so on. All these ones are very popular and occur much more. Louis had a version of that as well, but this I've got more in that one. And out at the right there, at 54 years, you can see a big one as well. And at 18 years, at 9 years, and so on. All these figures, most of these figures appear in Dewey's table. Not all the cycles he found appear in that table. That was just in relation to be noticed of some of them. What I did is more stuff was known since Dewey's time. I rearranged the table to horizontally and vertical for the ratios of 2 and 3. And I used 17.79 years, somewhere between his 17.75 and my 17.8, which was half of 35.6. And so I've put them horizontally in 2s and vertically in 3s. But he must have noticed he had a 1.11 year cycle and a 2.22 and a 4.44. He must have noticed that there was also an 11.1 and a 22-year cycle, which didn't fit with the 2s and 3 ratios. You have to put a 5 ratio in to get up to those from these other cycles. I can't help thinking he noticed that, but he didn't mention it because he didn't want to make it too complicated. I don't know that he noticed, but he had the stock market cycle, he had evaluated as 40.68 years. 3.389 years I've got down there is 40.67 months. And these other cycles that are in this lower part, were after dividing by 7, are in fact commonly reported in various solar phenomena. They're short period solar cycles, 155 days, one's called, and there's ones of half of that and a third of it and a sixth of it and so on. And that whole range of them all fit in exactly. And I found 1 wheat cycle of 1.695 years. All these things fit with these proportions of 2 and 3. And then an occasional 7, a 5, and a 13. Now, originally, I started doubling the cycles I found from these ones, and I got up to near 2,300 and 4,600 years, and it was all based on doubling. I had I had 2 possible formulas for the harmonics theory. One of them was all based on ratios of 2 being the dominant thing. So it's like the piano, you have octaves, right?
Yes.
I don't believe that's correct. You have to put a 3 in every so often, like Dewey did, and sometimes a 5 and a 7 and 11 and a 13 and stuff. So all the stuff that's based on only powers of 2, which I see many people doing and trying to do it, doesn't work. And the thing that trapped me here was that these cycles are 65 times the length of one of these ones, and 5 times 13 gives you 65, not 64. And when you check the period accurately, when I divide the accurate period together, I got 65.05. So I figure that's as near as you're going to get to 65, given that the data is not perfect.
Well, I want to also follow up just this concept of understanding the harmonics. You're moving kind of fast for my brain in terms of the mathematics, but I'm following the concept.
I haven't got to the harmonics theory yet. So these are cycles that are found right up to 586 million years. I had a geology book put together as a result of a whole bunch of geologists talking about cycles. And they said there are cycles of 600 million years, 300, 150, 74 and 37 million years. Now, 37 and 74, if we double them up, we'll get a little less than 600, right? But when I went to Russia in the 1990s and I gave a talk on harmonics theory, Professor Afanasiev, who's a geologist at Moscow University, came up to me, thrust his book into my hands. Now, he doesn't speak English and I don't speak Russian, but someone translated my talk. very well, I'm told. And he had 586.24 million years. What we'll see later is if you start from his accurate period and calculate it down with the ratios there, and all the cycles there exist, you get to 11.86 years, 11.8622 you get, which is Jupiter's period around the sun, and you get it to 6-digit accuracy. That can't be just luck.
Well, I'm also going to say that we're not going to get into astrology, but it's interesting that the seers and the kings and the politicians of old would really want to track what's going on in the celestial sky and try to tie it to human affairs. I'm just saying that's interesting.
Another
that's
connection,
all.
yeah.
Because the 12-year cycle and the 60-year cycle that the Chinese use, all of those things show up pretty nearly in this. Yeah. And if I calculate the harmonics in a circle, it gives you all the alignments that are the ones that they consider important. So there's some essential truth there, but a lot of modern astrology, if we get on to Fred Hoyle and Stonehenge, he went back and studied it all, and he found that that in actual fact, the knowledge that the Greeks learned about the eclipse cycles from the ancient Britons who went down there and told them. They said they learned it from these people that came from this island. They built this big circular structure. No, not the Greeks. The Minoans learned it, and they passed it on to the Greeks. So it's quite funny because we all think of knowledge coming the other way, but actually some of it went that way.
Yeah.
Wow.
Good.
That is fascinating.
This is one of my two favorite quotes. It's from Edward Dewey. Insofar as cycles are meaningful, all science has been developed in the absence of cycle knowledge is inadequate and partial. Thus, if cyclic forces are real, any theory of economics or sociology or history or medicine or climatology that ignores non-chance rhythms is manifestly incomplete, as medicine was before the discovery of germs.
Wow.
Now, that's a really powerful statement because, in fact, in most of those fields, people just totally ignore the presence of cycles, and they get things wrong as a result. If they can start to understand that there are cyclic forces coming from beyond the Earth, it's like discovering germs. We can improve things vastly from that.
Makes sense.
My other most favorite. Now, Dewey, in the same period of time that Dewey was doing this stuff in the last century, Chizevsky was doing similar things in Russia, although he had to leave at one stage and go to France because saying that cycles could predict things in Russia was against the communist doctrines because it was all caused by the struggle of the working class. So he said, life is a phenomenon. Its production is due to the influence of dynamics of the cosmos on a passive subject. It lives due to dynamics. Each oscillation of organic pulsation is coordinated with the cosmic heart and the grandiose whole of nebula, stars, sun, and the planets. Now,
I love that, the cosmic heart. Oh, yeah.
And I love his passive subject. You know, we think that we're in control of everything. We're not. We're dancing. The universe is playing the tune. The ancient Hindus had these ideas as well, ancient Indian knowledge, that there's all this orchestra of the universe and we're just dancing to it, you know. This one is my contribution. It's the axiom of the harmonics theory. Okay. It's not as pretty as the other ones, but we can find it does allow us to do some calculations. The universe consists of a standing wave, which develops harmonically related waves, and each of these does the same. Now, the first two lines of that, well, whether the universe is a standing wave, it's not, it may be up for debate, but the development of harmonically related waves is well known in physics and music and other areas. So that's not debatable, but my discovery is, and each of these does the same. Because when you apply each of them doing the same, that's when you get this whole rich structure of harmonics comes out. So let's start doing that. Oh, those were some of the cycles. Dewey said, everything studied by man can be made in a time series has cycles in it. There are common cycles periods that exist in many seemingly unrelated fields. The cycles with common periods exhibit synchrony, meaning they reach their peaks and troughs together. Many of the commonly reported cycles exhibit simple ratios of 2 and 3 and their products between them. Some of the observed cycles that fit these patterns are outside the Earth. So Dewey very reluctantly looked at this outside the Earth bit, I think, but he ultimately came to it. So this is my application of what I described to you. The universe, let's say the universe has got a frequency of 1. We don't know what, but it's oscillating and pulsating or vibrating at some frequency, presumably at least billions of years. And each that develops harmonics. So frequency 1, I've put the frequency along the top, 2 to 16, and 1 makes
2.
one unit of each, right? 1 unit of every frequency going up. And each of these does the same. So we made a 2. So 2 comes in and makes harmonics of itself, 4, 6, 8, 10, 12, 14, 16, etc. And 3 makes 6, 9, 12, 15. And 4, we had 2 4s. So at the bottom, I'm making the total. 4 occurred twice, so it's twice as strong as the others. And 4, so therefore, 4 adds 2 to each of 8, 12, 16. 5 produces 10 and 15, and 6 makes, because it occurs 3 ways, as 6, as 2 times 3 and as 3 times 2, it makes 12 as well. So what we see is when we start totaling, and we notice that 12 occurs a lot more ways. And people like to work in dozens in ancient times, 12 inches in a foot and 12 lines in an inch and all that. These things are natural. So that's beginning of the table. Now, I just want to make sure that everyone is clear and understands that what I'm doing there.
Okay. Well, and also base 12 and base 60 were once popular.
Yeah, they are. Yeah, right. Because 60 occurs as well. Yes. Yeah.
So
there's reasons for that. Yes. So we move on from that one. That's just a graph of what I did there. I'm trying to move this other thing around so I can see things. Where do I put it? Okay, that's good. And you can see there that how many ways, that's the calculation of how many ways each harmonic can be made. And you'll notice 48, 60, 72, 96 there, which if you divide by 12 gives you 4, 5, 6, 8. Those cycles I found earlier. Let's go a step further. I've now adjusted those so that I've divided them by the harmonic number. Now, the reason for that is as you go to higher order harmonics, they get weaker. So this is countering that effect. The number of ways it can be made, and it's getting weaker as it's made, gives us this thing, and this is the general form of it. And we can see the 48, 60, 72, 96. But we can see some other moderate ones there as well. And when we label those, 54, 56, 64, 80, 84, 90, it turns out that we can go do, re, mi, fa, so, la, ti, do. And we've also got mi flat and T flat. As I mentioned, the 2 black notes I found in the week cycles. So this explains the stuff I was finding in the week cycles. So quite clearly, this calculation is doing something very interesting. Not only is it giving the whole musical scale, it's giving you what happens in the economy and the wheat prices and other things.
Wow.
okay, so if the universe is a sea of vibration and its sounds follow the same principles as music, music is just a little subset of this giant vibratory dynamics. It's one that we can hear and see. Okay, so following, governing the same governing.
So the calculations up to there I did before I found out about this foundation of the study cycles, and that just shows up to 100. Then I started to write computer programs to do it, so this one's up to 1 million, my first shot, and you can see here that there's some peaks and troughs. There's a bit of a wavy sort of thing going on there. And you'll see in particular, so 12 and 24, 144 and 288, 1440 and 2880. Now 2880, our New Zealand's Bruce Cathy wrote books about harmonic. One of his ones is Harmonic 2880, about seeing UFOs in a grid. He finds a grid around the Earth with 2880. I did chat to him about that. He's died since then. 17280 and 34560. Now remember this number 34560 because it's the first really big peak. When we go on from there, this one here, can you see this right up to the top?
Yeah.
Because I'm seeing some little things above it. Anyway, this one that was up to the, I go to 1 million. I then went up to 10 to the 20, 10 to the 30, 10 to the 40, 10 to the 50. Every time a new generation of computers came out that could have more memory and faster processor, I could calculate it a bit further. This is the last one I did. We could do more than this now, but this seems to be adequate. And you'll see what's happening. The early ones, so I've done it in 3 sets of 10. That's from up to 10 to the power of 18, from 10 to the 18 to the 10 to the 36. from 10 to the 36 to 10 to the 54. And you can see that at the start, we can see the individual harmonics. But by the time we get even to the right-hand side of the first one, there's this great sea. It's all filled in. Now, your man that wants to ask the question, is there noise? It looks like noise. All that sea of stuff looks like noise. It's 1 upon F noise. They call it all 1 upon F squared noise, it might be, but 1 upon F noise probably. And then you can see a few stick out above the noise, and those are the ones we can observe. We can't observe those other ones hidden unless we got data that ran for millions and millions of time periods and analyze the cycles. We won't find anything below those top ones sticking up.
Wow.
And in the second row,
tips of the iceberg.
Yeah, in the second row, I've chopped off everything below 0.8, right? So you're only seeing what's happening above there, and the same in the third row. So now those things are, you can see there's sort of wavy nature to the top. And what I've done here is I've taken the envelope of the top there, right, going along. And at the top, I've put what ratios, I call this the main line. These are the most outstanding harmonics that occur. And along the top, I put 2, 2, 3, 2, 2, 3, 2, 5, 2, 3, 2. That's the ratio between members of this series. And we see we get big peaks. I've labeled them 1, 2, 3, 4, 5, 6, 7, 8. And they are typically, one is occurring at around about 3, at the harmonic 3, 4, 5, 6, 0. The others occur near powers of that number, but not at powers of that number. So the man who asked, is it fractal? It's not fractal, but it looks a bit like it's fractal. So it goes on and on with greater and greater detail. And so you'll see here that one ratio of the 5 occurs between each of those peaks I put up. But that every so often, like between 3 and 4, a ratio of 7 and 11 occur, and a ratio of 7 in that one. And eventually a 17 comes in, and so on. Now those, that's why when we look at this, we'll be finding that at these sort of ratios occur from the Hubble scale. If we start dividing by 3, 4, 5, 6, 0 typical numbers, we get the typical spacing of galaxies, the typical spacing of stars, the typical spacing of of planets, the typical spacing of moons. The next two, there's nothing really obvious. The one after that gives you typical spacing of cells, then the spacing of atoms, and then the spacing of nucleons, and the next one presumably the spacing of quarks. So this whole structure that we observe in the universe comes out from the harmonics theory. There's no other theory. It comes out from that one simple axiom. We don't have to do any clever extra bits. The other theories that explain the universe, or try to, like the Big Bang, has no good reason why all these different structures should form at such huge ratios of scale. And we can see in here are extra little peaks between some of them, which can correspond.
So what does this mean to you? Let's just pull back for a moment. So you're saying that the same dynamics that create the pacing, the oscillation, the cycles from galaxies to stars to cells, the atoms to the particles of atoms like quarks, it's all governed by the same principle, the same harmony.
Yes.
The universe is singing the same song from the astronomical to the infinitesimal scales, macro to micro. I think that's such a beautiful picture, isn't it, of coherency?
I think
when they talk about the universe as a miracle, of, how did this law of physics and that happen and this happened to create a universe that supports life? I mean,
they're not separate. They're all the same thing. Now, I've for a long time I've felt that the ether is the best way to explain all this. If I start to talk about ether to physicists, they get upset because they say, no, that was disproved. No, it wasn't disproved. All of these people, Einstein, Dirac, de Broglie, a couple of the others, all believed in an ether till the day they died. And the reason they think they disproved it is because their
instruments weren't fine enough to pick it up.
The Michelson-Morley experiment got a null result. The reason the Michelson-Morley gets a null result is they assume matter is something totally different to light, and it isn't. It's the same stuff. Here was the guy just before Einstein. Oh, darn. his name's escaped me. I keep forgetting things. You'll have to bear with that. Sorry. Anyway, he actually, a couple of them proposed that it may be that because electrons are electrical, that they also have something like the same nature as light. Because that is the explanation, that matter is made of light, but it's standing waves. It's standing waves of light. So yeah.
So matter would be standing waves of light. So define ether, because there's
Okay.
yeah,
There's a lot of different versions of ether. My version is that the ether is a continuous medium. It's a tensile medium. It's not particulate in any way. Democritus was wrong. There are atoms, but they're not the end of the thing, as we know.
okay.
The ether has simple rules. It's the wave equations that are used by Maxwell, perfectly derivable from an ether. They are the wave equations of an ether. So Maxwell's equations are ether equations, and people even use things like, one of the operators called rot, which means rotate, and so the local rotation of the ether, that's what that measures, and the local acceleration gives the magnetic and electric fields are the local rotation and acceleration of the ether. So now the question was, is that the universe, and are these steps the things that we recognize? And I set out to find out if that's the case. I started at 10 billion years because we know that the universe is at least that big, 10 billion light years. And I move from right to left here, going to longer time periods. And I took the cycles I knew about that I had periods for, ranging that from the 586 million year down to about a month or so. I put them all in, and I took my predicted pattern of harmonics. And on a log scale, what you're effectively doing is sliding them along and seeing where they match. And this little wiggly line shows you how well it matches at different points. And you can see something very spectacular happens at 1.482184 times 10 to the 23 years. You get an incredibly good match, but it fits all of that stuff. Now, you also get quite good matches at double it, triple it, 4 times it, and some other ratios. And that's because we know that the cycles are very similar at those ratios because of those 2s and 3s. So that's exactly what we expect to get if the cycle of the universe is really that long. Now, having got that period, it's rather interesting because that's 10 million times the age of the universe according to the Big Bang. So I'm going to say, I don't disagree with quantum physics. I don't disagree with general relativity, but the Big Bang is bung. Big Bang is bung. And so
I wonder if the Big Bang is just also a cycle, right?
Well,
is it a
yes.
one-off, or is it cyclical? Yeah.
It's interesting. It's interesting that they get. Fred Hoyle, who's a great man, he began to talk about it in that sort of way of creation events happening at different times. And certainly that sort of thing is possible. And some people that believe in the Big Bang are starting to say, yes, there are multiple occurrences and so on. Yeah. So that's moving towards that idea. Yeah.
He was also, because I didn't get to talk to Fred, but I got to talk to Chandra Wickramasinghe, his colleague, and they were talking about an eternal steady state as well.
Yeah. This is not a steady state, but there's some of he was a mate of Fred Hoyle, I think, and another mate of Fred Hoyle did some good work, Nalakar, which we can hopefully get to at some point, which is that the red shift is not cosmological. It's not caused by what they think it's caused by. It's caused by the frequency of particles changing.
Interesting. That's a whole other discussion.
We'll come to that. Yeah.
That's a whole other discussion.
So this here is the on the left are the calculated order of the different primes coming in, right, from the Harmonics Theory. Over the right, I've put some of the main cycles observed down and the ratios between them, and then I've put that there in a similar form to the others, and you can see it lines up quite well. You've got the 11 there. We've missed that 7. That must have occurred before that one. But we've got the right number of 3s and a 5 and a 5 and a 7 in the right places. So it's showing that it does agree fairly well. Now, I don't expect my calculation to be 100% correct, because when you form harmonics, the wave structures, it will be like a Taylor series that you get when you do sine and cosine calculations and all that. There's a Taylor expansion. And I do think there will be some other terms there other than the going up in the harmonics. So I do expect there's an adjustment. And the whole thing does seem to fail below when you get to the level of days. It doesn't link correctly to the 160-minute and the 80-minute cycle and the other ones that we know are shorter than that.
I got a question. So you talked earlier about when you were in the insurance industry that you did a mythical factor analysis. In other words, you know that there's some factor impinging the whole, but you don't know what it is yet. It's mythic. And so some people could say, well, your numbers don't exactly match up. It just must be, let's throw it in the dustbin. You could say, well, I'm seeing these patterns, but I'm also needing to account for mythical entities that I haven't yet discerned. I know they're there. I can't possibly know everything. The universe is so complex and there's so many nuances and factors. I can't possibly know them all. So where do you come on the spectrum where you can argue? Do people argue, and where do you come on that and say, I still need to account for the unknowns? Yeah.
I don't call the factor analysis mythical. I use the traditional explanation, that is that this is a variable which explains more of the variations of all the things we're looking at than any other thing can. So I don't see it as something existing in its own right, but as we get further on down and we start to find the cycles, then I do consider they exist in their own right.
Okay.
Gotcha. Okay. I know that's going to come up, so I wanted to ask it.
Yeah. So what I've done with that whole thing back there is I've taken a little bit of it and I've shown the periods that are predicted. By the way, I've got a file on my website. It's if you go to my maths explanation of the Harmonics Theory, I think it's linked there, or else it's on my main page. There's a CSV file of the harmonics that I've shown in that other one, just the strong ones, and more than the main line, but not all of them because there's too many. And this is a graphic representation of some of those, and I've put red arrows on some of the observed cycles. Now, I think the red arrows are Dewey's table, right? So you can see that they all occur right. I've plotted them exactly where they occur, and you can see all but that one occur right on the one at around 54 years, occur right on the place where they should. And then if I go further, and 11.8622 years, Dewey didn't have that in his table, but it's a period of Jupiter and it's very important. And that's one of the ones that comes out exactly. And then the red ones again are from there. The blue ones are ones from the astronomical things observed in the sun. And a lot of those other ones I haven't marked, but like, for example, the 2.965 year, that's one common one of Dewey's. So those ones are all occurring. But one of the fascinating things is in that part of the table, it has a cycle of 9.638 years. Now, the ones for the Canadian lynx has a cycle that's described usually as 9.6 years. The population of the lynx in Canada, they've been trapping them for furs since the 1700s. So they've got 200 years of data of how many they found. The numbers go up and down on a cycle of 9.6 years, roughly multiplying by, I've forgotten, it's more than 10 anyway. 10 times divide by 10, multiply by 10, divide by 10 every that often. And there are a bunch of other cycles on that same period. When Dewey lists them all, a number are listed as 9.6 years and a number is 9 2/3 years. So if we take the middle of those, it's 9.63 something, and that's what I get there right on. Now that figure was not put into my calculation of the longest cycle, right? So, but it says there should be one there, and there is one there.
Well, how do you determine what goes into this chart? The number of links that skins, furs that people are trapping? I mean, why that?
Yeah. Well, it's one of the ones that's used a lot because they have such long data for it. In terms of animal populations, I should mention that in 1920, something, or 1930s, it's around there, somewhere in the 1920s or 30s, at a place called Matamak. It's well worth looking that one up. One guy put some money towards getting a bunch of scientists to come up from America and Canada together at Matamak, which is in Canada, but not too far from the United States. And they talked about cycles they'd found. And this Canadian length was one. And there's another one, which is probably that 3.95 one, where a number of other animals are on a different cycle.
But wouldn't there be other factors for that number, like how many trappers are actually out there in a given year,
No.
what the economic benefits are to go out and collect these, what the popularity of the skins? I mean, there's so much involved in that.
But those things will vary gradually over decades. This shows you a huge increase and a huge decline in one decade. You know, it's very, very clear. There's no doubt that that's a real cycle. All cycles have other things going on. Yes, but there are methods of analysis which will highlight the cycle. So we can perhaps come to that later.
Okay.
This is my CSV file, which shows you the powers of 2, 3, 5, and so on, primes, how many powers of them occur down each column. And then these are the strong cycles, 1, 2, 4, 6, 8, 12, 24, 36, 48, and so on. And this is how many ways they can be calculated, they can occur. And then I've got, does that thing move? It does. Oh, that's nice. The log of the harmonic and the strength of the harmonic. So that's my calculation of how strong it should be relative to other ones in its vicinity. And then I've put how many, I've used the cycle period I got, whoopsie, pressed the button when I shouldn't have. 1.482 is the number of years for the number one cycle. So then I've just simply, now that's not actually in my CSV file, you then divide that by the harmonic number to get it. And you can do it in seconds if you want, because as you go down this table, you get, for example, to the, when we get to the 586 million year cycle that the geologists found, and the other ones they find, you find the ones that they found are the ones that are the very strongest ones in that range, according to the Harmonics Theory. And when we get down much further, there's my Tomes's number, 35.6 years, near enough in the years column. 22 year sunspot cycle, 17.79 is Dewey's starting point, 11.86. All of these ones are predicted to be very strong ones because of the strength they have there.
So what is this actually telling you? What are you concluding by this? I mean, somebody could argue that you're just putting in cycles that, are you cherry picking cycles to? No,
there's no cherry picking.
And there's so many cycles to choose from.
We have to ask,
Yeah, we have to ask.
Yeah, of course you do. No, there's no cherry picking. The cycles I put into the original one were the commonly reported cycles. The commonly reported ones from geology, from astronomy, from economics and other things. So I've been through that with some people in an astronomy forum and showing them how it went, and they accused me of cherry picking. And I had a 1.11 million year cycle and a 2.22, and they said, "What's that?" And I said, 2.22 million light years is the distance to the Andromeda Nebula, and the 1.11 million year cycle is a cycle in the solar system. It's an energy exchange between Jupiter and Neptune. Which causes the sort of pulsing of the solar system. Now, the guy said, no, the distance to Andromeda is 2.35 million light years. And so I checked, and that from the time that I'd done the calculation till then, they'd improved in that figure. But when I took all the local group galaxies and analyze them for multiples and fractions using what I call Kotov's method, we'll come to that, it gave both 2.22 and 2.35. So it does come out of astronomical data, even though I
you said it's interesting, there's a direct effect from Andromeda to our solar system. Are you suggesting, or our galaxy, are you suggesting that there's a exchange, or just that there's a governing pattern across the board to all of it?
There's a wave which has 2.22 light years and a 2.22 year period oscillating, and we're on the galaxies are on the nodes of these waves. I'll show you some other ones that make this very clear. Both at the larger scale of the universe.
There are larger waves in the universe that are oscillating galaxies, our neighboring galaxies, and ours, and these are significant. And you're seeing them because you can collect data from astronomy to Canadian trappers to everything in between. And so we're all singing the same tune. Basically,
literally,
we're all dancing in beat. We're dancing in sync. That's kind of your point.
Different parts have different emphasis of the notes. You can sit in one part of the orchestra or in a different part, you know. But I didn't finish my Dewey story because those guys had that conference. And
would you turn off your slide for a moment? And I just want to digest some of this and see what it means.
Okay.
Yeah.
Oh, you want to turn off the sharing?
I saw a sea of numbers, but I want to know, what does it mean?
Well, just talk for a few minutes,
You're obviously very versant with numbers, and you can read these charts. We're having to have you decipher them.
The other thing is the other thing, Ray, is we found someone who talks as fast as we do.
That is so rare.
So your brain is 1,000 miles an hour. I'm
slower than I used to be when I was younger. You're lucky.
Thank God you've slowed down.
Very good.
But I wanted to finish a bit about Dewey because he got with the he found out about this Matamek conference in about 1940-41. And so he instantly, at that stage, he'd been working mostly with economists and such people, business people. And so he got in touch with the guy that organized the conference. And within months, the other ones had said, we always intended to set something up permanently, and you've given us the push. And they set up the Foundation for the Study of Cycles. So that's how it started, with a mixture of scientists and people interested in business.
Got it.
And dare we say share markets and so on.
Because so business wants to employ this to really,
Yeah, and that's how it ran. I think even cycles organizations run in cycles. I found out about them in the late 80s and visited them in 89, where I gave my first talk there. And I went a number of times to conferences over the following years. In the mid-90s, everything started to go wrong. And I think the reason was that they started to concentrate only on share markets and not on scientific stuff. And those people began to drift away. In 1998, the Foundation for the Study of Cycles went defunct. Then, so in 2001, over the period, I was getting in touch with some other people. I couldn't get the mailing list, but I got in touch with a number of other people, and they agreed we should set up a new organization. So I set up Cycles Research Institute, which the Cycles Foundation had a big office with multiple staff and a huge library and all sorts of great stuff. And they did a wonderful job. But what I set up was an internet only, and the total cost of it was I could afford to pay for the store, putting the website on and stuff, and that's it. That's all it spent money on. And a lot of people promised me to do a lot of work, but in practice, I had to get their articles and put them on there and that. And so that's how it ran for a while. Then a few years later, the foundation appeared again, and I got in touch and said, "Oh, we're old members of the foundation. Let's work together." And they said, "You've got some material that belongs to the foundation on your website." And I said, "Don't make me laugh." I said, "You know more of the old foundation than I am." So I'm going to put it there. And so he threatened me. I said, "Well, sue me then." So after a little while, they decided that maybe they'd be better to work with me. And so they
good for holding your ground.
Yeah. So they said, "Come to their conference." So I went to their conference and I gave a talk at their conference. And then they also had worked on a fairly grand scale, but the guy running it, he had some good attributes and some bad attributes. And as a result, they crashed and he ran away. So that was the second demise. Then what happened was another guy decided to start it up. And this time it was done on a proper footing. The middle one didn't have a proper groundwork. It was basically a dictatorship. And it's now been set up with a proper board. And then I was invited to join them again, and we've done. So now Cycles Research Institute's there for historical reasons, and we still run a blog and stuff, but most of my emphasis now is on the foundation. So that's how it came about. We got to there.
Ah,
So when you look at cycles everywhere, can you just tell us a bit about where we see cycles in our own lives? I mean, you
Yeah,
mentioned the
more than the
litany.
obvious ones, but
Yeah,
yeah.
more than the obvious ones, so that we can see that indeed what you're describing is a universe humming to the
yeah.
same beat, this
Yeah,
orchestra,
well,
this beautiful
of course,
orchestra.
there's the obvious things like the
Yeah,
day, the week, the month, the year,
yeah, we know
except
those.
we've got months
Yeah.
wrong. But there are other ones. For example, there's a series 160 minutes, 80 minutes, 6 minutes, and 3 minutes. They show up in the solar system by the distance of the planets. They show up in the sun's oscillations. They also show up in our daily lives. The 80-minute one, in sleep, they say there's a 90-minute cycle. When I look at it, it's about 84 minutes. It's the same one. So that one shows up in activity cycles of people. There's other ones. If we look at the dimensions of the human body and nerve impulses, there's multiple different speeds of nerve impulses, but the one that seems to fit is the one that's about 1 meter per second. And if we have a wave going from our head to our feet and back at 1 meter per second, it takes, say a person's 1.75 meters tall, that takes 3.5 seconds. That's about the speed at which we breathe. If we run a wave around our chest at that speed, right, that gives you your heartbeat speed. If you do them inside your brain hemispheres oscillating, that gives you the oscillations of your brain waves. If you do it in your eyeballs, it gives about the frame rate that we can get eyes. So we're not aware of those things very much. Well, we're aware of our heartbeat and our breathing. There are other ones as well. So it does link into all these processes of the body. I've got some material there that will get to those. We could flash through to that part if you like. It might be a good idea. I think you'd enjoy those ones. Can I skip through to there?
Yes,
Sure.
you can.
Yeah.
Launch them.
Yeah.
Very nice.
And I just want to applaud all your work.
Yeah.
It's like,
It's been fun, isn't it?
yeah, I think you did very well in the markets early on, and it allowed you to retire and really devote this to your passion. And
Yeah.
and I'm happy that you've elucidated this. There we go.
Yeah, it's coming up.
I'll just do this little one briefly before getting to the other thing,
Yeah.
because it happens to be right before it. The structure of this chart I got from a book by John Gribben, I think it is. He got discredited for a couple of things he came out with, but he actually written a lot of good stuff. And this shows radius or wavelength running across ways and energy or mass running upwards. Now, the diagonal running from the left to the top is the limit of the universe from relativity.
Okay.
The one running from the left to the bottom is the limit of the universe from quantum mechanics. And the right-hand side is the limit of the universe for harmonics theory. Now, that was my original diagram with the universe at the top, but when I discovered that that wasn't really the universe, it was just the Hubble scale. Darn. I put a bit extra on the right because that scale is 10 million times that observable universe, right? This is a big scale. So you can put everything in there like stars, planets and everything and particles and stuff. Where that little line I put near the diagonal running up to from the left to the top is the area where general relativity works best. The little line down the other one is where quantum mechanics works best. They work just near those diagonals. Harmonics theory works through the whole thing, but it's most strongly at the right. But it works in all places because we find it in the planets and the stars and in particles. So that's it's more like a ghostly thing going over there, just subtly influencing it, right?
Yeah.
So now. That's now we're getting into the human body. That is the rate at which blood sediments in a centrifuge. Little peak every 3 minutes. So you can see 3 minutes is clearly pulsating through us, even when our blood's taken out of us. This is one I did where I put a speaker underneath my thigh and recorded what happened. The very short oscillation are nerve impulses. The medium one is the heartbeat, you see the little yellow line there, and the bigger wave is the breath. And you can see those things are present throughout the body, those cycles.
Yeah.
Anyone can record that, put their speaker underneath their thigh. This is looking at acupuncture. Oh, hang on, where's the other? Let's go to the other diagram first, this one. My friend said to me, I have to look at the
Leonardo da Vinci.
life. So, yeah, so I took his band because it's one nice one with proportions, right? And I've put the number one wave over the top. And as we do the second harmonic, it gives you the base of the spine or the genitals. When the strongest harmonics go 1, 2, 4, 12, 24, etc. That's when we put the 4 in, it gives you the heart. When you put the 12 in, it gives you those places where the red dots are, except the top one there, 24. And that's the places where people say the chakras are.
Oh.
The one at the bottom of the nose is not said to be a chakra unless you read Yogananda's book, and he says there's one at that level as well. Right, so that's the, now did I have those other ones before or after that? Oh, they were before, weren't they? So now when we look at the human body, those are the acupuncture layers there, and it shows you the spine. Buddha talked about this fathom long body. Fathom is 72 inches, right? Which would make the unit an inch. In actual fact, we're mostly a little bit shorter than that, but still, you can see the layers of the acupuncture points, they're inches. The spine and the ribs are in inches. More of them there. We're made of inches. If you look at a face, it's made in inches. Chin to the middle of the mouth, 2 inches. To the bottom of the nose, 2 inches, 1 inch. To the middle of the eyes, 2 inches. To the eyebrows, 1 inch. If you look at our fingers, they're made in inches. Do you want a quick flash of cymatics?
Yeah.
I saw a cymatics pattern, yeah. But go ahead.
This is my cymatics experiment. I used my speaker not just for under my thigh. I stuck a little dish on it with some water in. I originally just started getting into this because when I put down a cup of tea on the table, the bang made a little wave come from the outside into the center. So I started jiggling it to try and make the wave stronger. And when I got just right frequency, a jet of tea went into my eye. And I decided there's got to be a controlled way of doing this. So this is why I made this. Now, what I had is a light shining onto the water and a video camera where the angle of incidence and reflection would be, right? So when you have no waves, it's all white. So what we're seeing here is the pattern as the vibrations are going, just putting one frequency into the thing. And you can see that there's a few little circles near each other there, a few other sort of tentative circles, and see little ladders running out, like one to the upper left, one downwards, one to the right. There's a few of those everywhere. This is the inner part, and I've labeled them A, B, C, D, X, Y, Z. Like we say Z, but I'll say Z for you. And the red ones and the blue ones are labeled differently because all the red ones are an even number of half wavelengths apart. We get light at the top of a wave or at the bottom of a wave where it's horizontal, and we get dark where the water is tilted. And so we're seeing A to C is 4, to Z and to Y and to X are each 2. But from A to D and C to D and A to B and B, C, they're 3 half waves apart. So those two, when those one lot are up, the other ones are down. And when the other ones are up, the first lot are down. All right, does that make sense?
Yes.
So effectively, we've got positive and negative charges, if you like, if you want to think of it that way, as these being particles.
Okay.
The relationship between these are fascinating. If we put some lines through them at the wavelength, we can hit exactly on all of those strong waves with the tops and bottoms of every wave going in that direction. We can do that in multiple different directions. When we put the circular ones, all of them are lying on the circles at half wavelengths from each other with the correct polarity.
So you're saying the proportions of those points follow this harmonic pattern?
Well, yeah, it's just a wave pattern. It's not really about harmonics here, it's just waves. This is a case of showing how that works. In the mirror image of that, you get 8 different directions in which you get ladders of waves coming out. So there they are all together. And you can see on the bottom right one, I've shown some of the ladders. And that shows you how one simple oscillation in a cymatics type experiment can make things which are very like particles with two different charges. Now, this is only in 2 dimensions. In the real universe, we've got 3 dimensions and the waves are coming from all directions.
Right.
But what I think is fascinating is that all of these things are fitting in with every other one in terms of their distances. Now, we're used to crystals having that sort of structure, but we're not used to amorphous materials. When I do that experiment, it starts off with just a circular pattern coming to one circle in the middle. And as I increase the volume, it then makes one circle with 6 others around it, a stable pattern. And when I increase the volume a bit more, it does this, and then these things are dancing around all over the place.
Right.
So it's more like a liquid. We've gone through little states of matter. And I think that it's quite surprising that in the universe, these things are all lined up. When I do the same analysis on the stars, I find the stars also line up on waves with each other. And we find, and the answer you get is 4.43 light years, agreeing with Dewey's 4.44 and my 4.45. So, and they are on a grid, but it's not a rectangular grid. It's slightly off, it's a rhombus. And the reason is that the diagonals don't work if it's rectangular, but if you go slightly off, you get 3/2 and 4/3 as the diagonals, which are strong cycles in their own right.
So you can see the whole universe in a teacup. I remember going outside in Seattle during an earthquake, like get out of the house during an earthquake and going to there was a small pond and seeing that pattern on the pond, on the surface of the pond, and thinking, that's the Earth's, that's going through the Earth
and cymatics
vibrating that pond.
Yeah, that's the ultimate cymatics experiment.
So, anyway, what's this showing us? This is
so when I put on the when I came to this idea that everything is the ether and particles are just the same sort of waves as the galaxies and all the other things, I put that on the internet. That was the early 90s. I got an email from a man named Milo Wolf, and he said, welcome to the club. I replied to him, what club? He said, the club of people that understand that matter is nothing but waves, because the physicists had this wave-particle duality. And I said, how many people are in the club? And he said, 2 now. but within a year, there were 10. Within a year, there were 10. And in actual fact, there were 2 before him that weren't in the club then. So, and in fact, I believe de Broglie was in the club. And the guy that did the maths that Einstein used, what was his name? Oh, I had it in my head before. When Maxwell did his equations, the smart cookie, he worked out there are solutions to this that are standing waves. That must be what atomic atoms are. They only knew atoms, they didn't know atomic particles then. That must be what atoms are. And he invented Clifford algebra, he invented. And Einstein used that in his calculations. Unfortunately, this man died rather young, and so he didn't get to tell the world how matter was made.
Interesting.
So what you're seeing here, Milo
I do
Wolf,
want to get to the part where Indian philosophy has intrigued you because it's saying something similar in its own language.
Yeah,
right.
This is the slice through an electron according to Milo Wolf's calculation, and that's looking and cutting 3 ways. Yeah, so let's go to, that's where I predicted a new particle which was subsequently found.
Really? You predicted a new particle and then it was found. What particle?
I predicted it as being 68 times the mass of an electron and 1/27th of a proton or neutron. About 3 months after my prediction, something appeared in New Scientist saying they found this thing. And there was an article in a peer-reviewed journal. And I had a debate with a guy, a physicist, who said, no, there's no such particle. I said to him, look up these experiments. Okay, yes, they found something, but it's not accepted as a particle. I said, if it had been predicted by your standard theory, it would be accepted as a particle, wouldn't it? And he said, yes. As I said, you found something that was roughly right, and that will do for the Higgs boson. This is actually something that was found, and the mass they give is 67 times an electron, but it's not particularly accurate. So I think my one's probably right. And this is the relationships with ratios of 2 and 3 between lots of the subatomic particles. And you'll see there's a 17, a 19, and a 23 in the ratios as well, which are in the correct order. We expect the primes as we go down to the smaller and smaller scale. So most of these are all the particles that have relatively short lifetimes in the listed in books of particles at one time. So, yeah.
So a lot of your theory is based on assemblage. You can find these same values, these same patterns over and over and over and over and over again,
over and over,
large to small scale. So your prediction is they must be affecting even more phenomenon wherever you look. That's the basis. Okay.
India, you mentioned India.
Yeah.
Because we have patterns of 2 and 3, and occasionally 5 and 7, Pythagoras did all his stuff on ratios of 2 and 3. And he had a problem because when he did it enough times, he came back to the same, when he kept going up by fifths, it didn't come back to the right place. He had Pythagoras's comma. It missed. But the answer to that was supplied by the father of Galileo, the famous Galileo. His name was Galilei, was Galileo's, and he put a 5 in there. He said, no, when you go from C to E, that's actually a ratio of 5 over 4, not 81 over 64. And he's right. Most of the time, that's the correct answer. This is Indian music, as I found in a book by a guy by the name of E. Clements in 1912. All the ones in one octave are shown above each other. So 2s are called the same note. This is Indian, the same as in Western. 3 are shown horizontally. So we go up by a ratio of 3. But note, when we go from 240, if we multiply by 3, we get 720. But we halve it to get back in the same octave and make it 360, right? Ratios of 5 are shown diagonally to the northeast. So if we have a 240 and multiply by 5, we get 1200. We drop it 2 octaves to get 300 there.
I'm just
and
trusting
ratios
yeah.
And ratio 7 is shown in those few extra ones upper right. Now, Clements was obviously very aware of the ratios because he gave those frequencies that I put on there. He didn't have a chart like this, but I assembled it from his numbers. And you can see, and it's obvious he knew a 7 because the flat he made for re flat has got a 7 on there, right? It's got a line with a 7 on there. So he's obviously aware of those. And so now the bottom, the frequencies in hertz, hang on, I'm having to juggle little things on my screen here. Down the bottom right, I've given the Western names for things, and the pa, da, ni, sa, ri, ga, ma, pa of the Indian scale, and the frequencies that are used.
Hey, what's the point? What are you trying to show us? A correlation between,
Okay, around the Earth is the Schumann resonance, about 7.5 cycles per second, right? That's the electromagnetic wave going around the Earth. That's the period in which it oscillates. If you multiply that by the strong harmonics I predict, you get this Indian music scale.
I see.
So I believe that they are tuning into these harmonics of the Earth, bringing those up, right?
Yeah.
And not only that, they don't make Pythagoras this mistake. They've known this for a long time, and they play it by, I believe, tuning in. So they've got both their feet in the other camp, not the physics one. Right. Clemens had a foot in the scientific camp to do that.
I see.
Can we hear some Fred for a moment?
Oh, Fred is okay. Sure, Fred.
We had a Vedic scholar with us. So he's putting something in the chat room.
Okay. Hi, Fred.
And he's very versed in the.
Okay.
Hello, Fred. Let me just add, hi there. Nice to meet you. Just a footnote on Indian scales. What Clemens wrote in 1912 is way out of date now. As we've come to know a lot more about the composition of Indian scales or ragas, and a raga really is a scale. but there's 100 different ragas and 100 different scales. So the ratios are not always the same. For example, you could have like Bhairava, which would go something, excuse me, I haven't spoken to anybody but my bird this morning. So sa re ga ma pa da ni sa ni da pa ma ga re sa. So you can hear that they're not all even in their intonations there. So they won't come to the same differential.
But if you look at that diagram I put up there that he had, there's one part that's colored slightly different that shows the notes of one scale in that section. And you can, as you say, there are different ones. You can go here, there, everywhere. You can find another set. So I think what you're describing is actually within that diagram of his. He may not have explained that, but I think it's there.
Okay.
Yeah. Very cool.
Yeah.
Yeah.
I'll have to look more closely.
How could the sages of India determine the Schumann cycles? I mean, how do you go,
oh God,
I'm tuning into this?
Classical Indian mathematics, especially as you go from the earliest possible periods on up, which is something I've looked into. Just the way they do mathematics is very different. And if you look at the very, very, very earliest Vedic textuality from the second millennium BCE, you'll find certain numerical differences that are very significant. You have 2s and 3s and 4s and 5s and 7s, 11s, 33, like that. You don't have any prime numbers beyond about 7 that are there, but you will have a lot of numbers that are significant in the composition of, for example, the adaptation of mantras from the oldest text called the Rig Veda to one just about equally as old called the Sama Veda, which are sung in entirely different ways. And the way that those are arranged and for ritual purposes will have different differentials. There's a book kind of by a guy named, what was his name? Wayne Howard, called Samavedic Chant, written about in the late 70s, all with Western musical notation. You might want to try to find it. I'm sure it's available in libraries.
Yeah, thank you.
That might be interesting for you to correlate with your stuff.
Yeah, I have found an occasional unusual thing like that in Western music. I did this thing, an invention I called automatic just intonation. It was a method for tuning a keyboard so that it would change the frequencies a bit to be in whatever scale you're in correctly. And I started doing a couple of bits of music in that to show how it worked. And I picked one of Beethoven's ones. I did one of Beethoven, one of Mozart, and one of someone else. Beethoven, there's one of his pieces. Normally you get the 2s and the 3s and the 5s and the ratios, depending on those. But in one of Beethoven's ones, he has an 11 and a 17. And when you play this piece, you hear these special notes. Oh, so what happened there? And so that was, I'm sure, was his intention to do this this thing. And Mozart always said he just heard the music; he didn't invent it. It's in the universe. He picked it up and did it.
Interesting. Thank you, Fred, for that clarification.
Yeah,
that was interesting. Thank you.
So
I want to add a couple things.
Yeah.
I think number one, this whole concept of sacred geometry has been bandied about for the last 20 years or whatever.
Oh, longer than that. It's got deep history.
Yeah, it goes way back. Well, I'm saying the term has been used in a way that, it's kind of ended up in the metaphysical world rather than in the physics. But what we're seeing today, there's physics at the foundation of what we refer to as sacred geometry.
Yes.
Yeah. I think that was important to kind of bring that to light. And I also thinking that, and this is a great example of those of us that are less familiar with the mathematics and all the research that you're doing. Zero familiar with it. Yeah. There is a great opportunity for us to see the worlds of music and mathematics coming together and understanding how they're the same. They're an expression of. So I appreciate that as well.
Yeah. In my life, I have this annoyingly trend to want to analyze everything. And so I wanted to know, I heard people talk about theory of music and I thought that's not the theory of music. And I wanted to work out what were the real ratios in this tempered scale wasn't right. And I worked out what are the real ratios in music, and then I discovered that had already been done before. It's called the just intonation scale. But that was one thread that I had going on, this thing in my life, and cycles was another, and there were others. And it's like a rope appeared. These things wrap themselves around each other, you know.
Yeah.
Sharon Rose has an interesting question. Sharon, do you want to pose that?
Oh, yeah.
It's actually about the math of the standing wave. The calculations you were talking about with Maxwell,
Yeah.
that does he include pressure mediation in that calculation?
It's what Maxwell does and how I interpret might not be the same.
Okay.
There is tension in the ether.
Okay.
I find the best way I can think of it is I get a bowl of what we call jelly and what Americans call jello.
Yeah.
And you give it a bit of a wobble and it goes all over the place, right? That's doing exactly what the ether is doing, in my opinion. Or you can get a block of steel and whack it with a hammer. It'll do the same thing, but it's too fast for us to see. And in the case of the ether is vastly more fast vibrations than steel, which is vastly more fast than jelly. Actually, there's a couple of other slides I should show you that are very important in relation to that. If we can, am I allowed to go back to the slides again?
Could you define pressure mediation, though?
Thank you,
Pressure,
Sharon.
you're just accounting for pressure.
It's tensile pressure. You can call it pressure. The ether, yeah, I think of it as tension, but you could call it pressure.
Okay.
Because if one side moves, the next one goes.
So you're describing, may I ask this question? It seems to me that you're describing a crystalline matrix to the universe where we don't generally recognize crystals, meaning that there's ordered patterns and they're fluctuating. Yeah. There's a flow. I mean, we know energy flows through certain lines, right?
Yeah.
Positive, negative, whatever. So you're saying that there's a hidden structure to the entire universe, and us included, that is lines of influence, that's lines of harmonics, that's line of vibration that oscillate differently, that are activating us in a way that we're not even aware of. Is kind of what I'm gathering.
Lines occur. Yeah. Certainly there are lines, and people talk about these ones through the body, and there's ones on the earth and that sort of thing. And in space we see some lines, but basically the flow of the energy is through, waves.
Right. But you're describing if there's a periodicity between this galaxy and these stars, our cells, that's a crystalline matrix in a sense. Yeah. I mean, it's moving, but you think things are ordered.
Crystal has a connotation that I don't like. And so
I agree, but I don't know any other word to
made of
describe
atoms. So to me, it's a continuous tensile medium,
right?
Which
it's flowing.
Which
it's
not very many people talk about. So so the energy can travel in every direction at once. Yeah.
Okay. All right. I don't have a word for it.
The lines do appear for various reasons. Yeah.
The spatial orientation or something like that. Yeah. Okay.
Yeah.
And you wanted to share a couple more slides.
What were you going to show?
I do. Yeah. So this is the structural scale of the universe in these big steps: galaxy, stars, planets, moons, cells, atoms, and all of that. That's what I think we observe, and that's the theory of it. But if you can have these big ratios between distant structures, can that also apply to velocity? Because it applies to both time and distance. So could it apply to velocity, which is distance divided by time? And the answer is yes. And the easiest way to think of this is, for example, if we have an atom, the energy of the atom wave is very small compared to the energy of the protons and neutrons. So when atoms bump against each other, it's not as strong as when nucleons do. But the mass of it is the atom. So when atoms go bumping together, they don't push each other anywhere near as fast as what light does. In fact, they push against each other at the speed of sound. Can you see my arrow, my pointer there?
Yes.
So that's one order. 10 to the power, we'll call it 10 to the power of 3.5. That's the big ratio steps in the harmonics theory. So we go from light to sound. If we divide it by that again, we get what's the typical speed of heat or nerve impulses. Now, people don't talk about the speed of heat, but heat is a wave equation. It behaves exactly the same as sound or light. It's so slow we don't think of it as that. If we divide it again, we get the typical speed of ocean currents. And if we divide again, we get the typical speed of continental drift, right? Continental drift is about 1 centimetre per year of the order of. And these things do fit quite accurately to that. And within each one, you find multiple extra detail, just like you do in any of the other places. Now, if we look at that, continental drift, that's earth, ocean currents is water.
You've got all the
air,
5 elements,
fire,
6
ether.
elements.
That's
Yeah.
the sort of classical elements. So whether they were onto that or not, it's possible they were. The Theosophical Society try to describe these things, and they talk about inner octaves, which I think is the things within these and these other things. I think people are trying to describe this, but having difficulty putting it into words.
So we're not physicists here.
Yeah.
When you describe this to physicists who can, or mathematicians who can follow a little better, what is the reception that you get?
Yeah.
What are their main challenges to understanding what you're trying to say?
The first big challenge is using the word ether. So I have to say electromagnetic waves. I have to try and change my language to work with them, but they're so convinced. The guys in quantum physics tried to convince the old order of what they were doing. In the end, they all agreed amongst themselves, we're never going to convince them. We just got to teach the young and wait for the old ones to die off, and that's what they did. And I think this is how things work. There's a few people that are seeking and searching that will listen, and hopefully some of the young get taught the same thing. So my ambition now is to try and get the young to do this. I've actually got a charitable organization that will offer scholarships to people that want to take these things further for certain aspects of that. If you find some people that you believe that are young and believe that could take this further and write papers on it and stuff, I'd be interested to talk to them. Can we do share again in a moment? Because I didn't quite get to the juiciest part. Here you go.
Okay.
Okay, I have one other question. So people who are feeling, okay, yeah, the universe is a sea of vibration and a sea of energy. We're looking at matter, not looking at energy enough in the relation between the two. How do they take to your theories?
Oh, yeah. Well, as I said, when I first put stuff up on the internet, the alternative health people started chatting to me before I even mentioned anything about that, right? I hadn't done all the stuff about the human body.
That also applies to the body and the energy body.
Those people take to it like crazy. Yeah.
Okay.
And I've talked to some people that are sort of in both camps, or mainly in the one camp, and they take to it very well. Yeah, it's only the physicists and astronomers that don't. They'll catch up eventually.
Yeah.
So what I've done here is I've taken that thing of the different scales in the universe along the top there, right? And I've taken these scales of velocity down here, and I put them together. And so what we've got here, this is another version. We've got the different speeds going upwards and the different scales of the universe going across. Now you'll see 3 arrows. Cycle period is going up in that diagonal down to the left direction. Wavelength is going up that way, and the speed of the vibration is going up that way. So now what happens? What use is that? I call it the universe wide web. The basic rule is if things have the same wavelength, they can interact because their nodes are in the same place. They're all interacting. If things have the same, they're interacting as well. And so here's an example here. When we look at the stars, we find distances in light years that are 11.86, 8.89, 5.93, 4.45 years. Those periods that we found in the cycles on Earth, they are present as distances amongst the stars. But the planet Jupiter orbits the sun in 11.86 years, although it's at a planetary distance. So we come down this one, and we find that the planet meets at the speed of sound. Now Jupiter orbits at a sound, the speed of sound is typically about 10 kilometers per second in different solids. And so we find here the meeting of the wave of stars with planets, and that travels therefore at the speed of sound around there. Now I've put a bit of extra lines around there because it's not one point. There's a strongest wave, but there's a whole structure around there, as I've shown you, that happens around all those things. And so this can be used for interlinking between all the different things and how the linkages work on down and cascade. How's that?
So with continental drift and with water currents and with like an ocean and with, you're saying, and even the atmosphere, you're saying that our Earth is compatible to receiving the energy from the universe. It's part of
Yeah.
it.
Yes,
And
absolutely.
it is part
Yeah.
of that matrix. And just as we are tuned to inhabit this planet so that our biorhythms, our circadian rhythms, our oscillations, we're brain
Yeah.
tuned to the Schumann in some way, we're geared to this planet in ways that we
Yes.
don't even know.
Right.
The earth birthed us, we're her children. She's communicating
Yeah.
with in these subtle ways. We're part of her matrix. You're saying that so this planet, and you can see by these particular
Yeah.
chart, the things that you've charted, is
Yeah.
part of the matrix of the entire cosmos, and it's all in a harmonic.
Yeah.
That is a beautiful picture.
Right. Right.
That
Yeah.
is a
So
beautiful picture.
if you take that one at 8 hertz and come up that diagonal
Yeah.
until we get the speed there, that's the that's the nerve impulse in the human body. It's on that vertex,
Okay.
and that's a moon wave. That's the speed at which the waves form the moon comes. The planets form, in my opinion, the planets don't form in random places. The inner planets form on the nodes that form at 3-minute light-minute distances or 6-minute standing wave. The outer planets at 80 and 160. That means that when you then look at what they're made of, the outer planets are made of hydrogen and hydrogen 1, hydrogen 2, helium. 1, 2, 4 are the atomic numbers. The sun is made of those too. It's on that wave, 1, 2, 4. When you look at the Earth, if you start the atmosphere, what's it made of? Mostly nitrogen 14. Remember 14. What's the crust made of? Mostly oxygen and silicon. Silicon is atomic mass 28. What's the core made of? Mostly iron, atomic mass 56. 14, 28, 56. According to the physicists, this is a coincidence. According to me, it's because the wave that the Earth is on is 1/7. The frequency of that wave is 1/7 the frequency of the outer planet's wave, and therefore we have 7 times the frequency of particles, which means 7 times the mass. Mass and frequency are the same thing.
Okay, so this is beautiful. You're suggesting that even the elements that coalesce to create this inner planet versus the outer planets are meaningful according to your harmonic theory, according to this wave matrix, that there's no accident that the heavier elements became the inner planets, even though the sun's hydrogen. And oh my, who's ever said that before? That is really interesting.
I
might be totally crazy, but it's really interesting.
Well,
oh my God.
The physicists tell me, oh, that's an interesting coincidence. I say, oh, yeah, I've got lots more of them.
The coincidences continue.
Oh my God. Do you have more slides that you want to show us? Or
we're running out of time too.
I know we're running out of time, but that is really
so it's important to say,
like I could not follow all your numbers and your math, but I appreciated knowing the work that you put into them. I appreciated the charts and your decipherment of them. I appreciate your showing that there's a lot of deep research that you put into this theory. But I find also so interesting your conclusions and your observations and your conjectures. Like, what does it all mean and what's it all for? I mean, it may not, maybe some body of Indian music twigged on this or coincidentally on this, but this you can't argue with the earth and the placement of the elements and where they are lined up in our solar system.
No, you can't.
Yeah, that's a fact. Now, is it a coincidence or not?
I did this stuff in an astronomy forum, right? And I started several threads. It's called, you have to be against the mainstream. You disagree with their stuff. And so the rules for that are you have to answer all their questions, but they don't have to answer any of theirs. So I did these, and you only got 30 days, and then it's chopped off. So I did 3 or 4 threads on different parts of this with one of their people. Anyway, then they seized on something which they totally misinterpreted and banned me from the forum. A large number of people said, what did you do that for? This is really interesting. Yeah, so the common people could see it, but the ones in the professional astronomers couldn't. So I'm just showing there that it divides both time and space in the same things, right? Because it's the speed of light waves. That's the waves through the outer planets and the inner planets, showing that the outer planets fit very well to the distance waves. The inner planets don't fit so well to the distance waves, but they sort of fit. Mars doesn't. That's a calculation using this guy, Kotov's method. showing how it predicts the 2, the 3, and the 6-minute wave, and the 1860-minute wave. Those distances are in astronomical units, showing that pattern is present in the solar system without me doing anything but using Kotov's formula.
Okay.
This is the waves in the sea. The 6-minute, 12-minute, 18 minutes, 10 and 20 minutes. There's also 40 minutes, and it links to the 1860. So, though, according to the standard theory, waves in the sea depend only on the depth of the sea, the period of them. They don't. They strongly show these these other ones. These are rocks. These are some rocks near where I live.
Oh,
they look like someone laid tiles, don't they?
Yeah, yeah.
If you look at them, there's 3 in that one, 2, 2, 2, 3, 3. I put music on them. Someone said, "Are not rocks frozen music?" My answer is, yeah, it's rock music.
New definition. Yeah.
Yeah.
You can have some band who's gonna want to play this. So.
Yeah. So that's the history, Stonehenge and stuff. People understood cycles then. They understood the motion of the sun, the moon, and the invisible one, which is the node of the moon's orbit, back in those times, right?
Mm-hmm.
The Hindus probably before that, but certainly by their Hindu and Buddhist cycles, Greek astronomy. Then we came up, Galileo, Kepler, Newton, who did the astronomy. Juglar, Jevons, and Herschel did the first stuff in cycles, and Chizevsky, Wheeler, and Dewey were the first ones that did interdisciplinary cycles research. That's the beginning of that, which I'm following on the tradition of. Dewey was a very careful man, you know. He was an economist. He did things carefully. There is considerable evidence that there are natural environmental forces that alternately stimulate and depress mankind in the mass. These same forces may also affect plant and animal life, whether and even such normally unchangeable things as chemical reactions. The chemical and the atomic reactions are interesting. That's another whole area. I did some analysis on that, but there's a whole lot of research other people have done on that. I found that the 3 and 6-minute cycles do show up in the rate of atomic decay. And the Russians have shown that atomic decay both shows the Earth's rotation, both sidereal and synodic, and the moon's period and the year. All of those things show up in radioactive decay of plutonium.
So unchanging things, supposedly, such as chemical reactions,
you're
saying that there are
cyclical. People can go back and look at them if they want on the video.
You're saying that there's a cyclical oscillation to such things as chemical reactions?
Yes. All of them turn out to be the same thing. They're all influenced by the same thing, which in my view is just all these waves passing through the Earth. Picardi was the original guy, Italian guy. He found some experiments. When you do chemistry at university, it's different to physics. In physics, you're supposed to get the right answer. In chemistry, sometimes you get the right answer, and somewhere it's called Cook's constant. You cook your results. Anyway, Picardi didn't like this, and he's a long time ago, getting on 70 years ago or something more. He started doing he found the chemical ones that people had most trouble with, and he did them, and he found, when he did them on successive different days, he got a graph. The thing did a different thing all the time. He thought, there must be something coming in from space, you know, or the sun. So he did them underground. When he did them underground, it was totally different results. The reaction would go only one way at certain depths, and another depth it would go the other way.
Yeah.
So these rays from the universe weren't reaching enough under the ground. So that's
Okay.
Now, when the Russians did their experiments with radioactive decay, they say the cycles for that, which can be detected all over the Earth, are the same ones as the chemical reactions. So it's the same thing happening. Do you know that when they separate human blood in a centrifuge, which they do hundreds of thousands of every day all around the world, if you plot a graph of how long it takes, you get a waving graph that fluctuates by like 100% over the period of a couple of weeks.
Wow.
They don't tell you about this.
No, you didn't.
They keep it quiet because they don't know why.
Oh my gosh. My gosh. So you're saying your harmonics theory might possibly answer some of these interesting anomalies.
Yeah, it'll help with it.
Yeah, would help. Well, I can see you have much more to do. But in the
There's a lot
time
more stuff.
remaining, show us
Yeah.
the most important piece of data, and then I just want to spend a few minutes. We're going to go over time.
Yeah.
Like this has been on turf that we're not normally versed in, so it's taken us a while to absorb this. You're talking
Yeah.
about things that we're not experts in or have any
No,
real background in. They
that's
don't
good. I'm
teach
glad
this
you're
in
open to it all.
school. Yeah. So-
The 160-minute cycle on Earth. If you like to look at Wikipedia, you can see the state of current knowledge. The establishment have got control of that page, and they said, "Oh, there was this stuff happened, but it's not true." I just want to show this is solar X-rays from this satellite measured every 5 minutes. This is a log scale. So these ones here that I've marked the little dashes there on the left, you can see that they're going up by more than 10 times, 10 to 30 times higher X-rays in the space of a few minutes and then back down again. And you can see that those things fit fairly well. And the ones at the bottom right fit even better for 160-minute bursts in X-rays from the sun. They say the sun doesn't vary. Ah, yes.
Okay.
So that's one thing. Now, this is if you look at the Wikipedia page, you'll find there is suppressed knowledge. I've tried to put stuff. I created a cycles list in Wikipedia, and that exists. But a lot of the other stuff I put, the knowledge, the Afanasiev's method of measuring the ages of things. I put an article about that, deleted. I put other stuff, deleted. All the stuff, Harmonics Theory, someone put, deleted. They don't want people knowing about this stuff. There's a concerted effort to delete things. I don't want to sound like a crackpot conspiracy theorist, but I can tell you that in lots and lots of areas of scientific knowledge, stuff is suppressed.
I've heard that before. And can we turn off the slideshow? Really, we have to just talk about what this all means. I know you have oodles more data, but
no, that's fine.
I think that there's a war of worldviews going on, right?
Yeah.
And it has been for time immemorial, right? Through our history. And I don't know what the deletion, Wikipedia is famous for deleting things. TED Talks are famous for not allowing certain topics on. I guess they have a mission and they're going to stick to their mission, right? So I'm not going to comment on that. But you're saying that there's far more variables going on. There's far few constants that we have to depend on, that we're far more influenced by this cosmic flow, ebb and flow, than we know. And it's affecting our biology. It's affecting our energy fields. It's affecting all of life here on Earth, everywhere then it would be. And that it's affecting these subtle phenomenon that be beyond what we know. There are few constants in the world, in the universe.
And I want to pick up on something you said about the changing world order. Yes, I agree. The changing world order. I saw a TikTok or a video, something by a lady, and I can't remember her name, but I can find it out again. And she was saying there's a conflict. There's the current economic Western order running things, and there's a new world order that wants to come in. And she said, and it's going to be much better. There's people with different ideas, and you know what we're talking about. And I love the way she expressed it. She said, I think that what we need to do is sit down and hold the hand of the old world order, hold its hand while it quietly dies, and comfort it so that it doesn't thrash about and hurt anything else. And it was just so beautiful how she said it.
That's women's wisdom there, isn't it?
It is, isn't it? Yeah.
Let's acknowledge, I acknowledge you for all that you've done and all of the gifts and everything you've done, but your time is done. And you must let the children now take over. And
don't be offended, but I'm pulling the plug.
Bring on the children.
Oh, wow.
And it also appears that people have said the cracks in the old order are what allows the new to rise up and fill the gap. And when the old ways are no longer answering all the questions or solving all the problems, that's when we turn to That's why the market.
Before you pull the plug, I've got to say thank you. Thank you both very much. You're lovely people, and I'm very grateful to be on your show and to share all this with you.
Thank you for the goodbye, but I'm not done yet. But I want to say that because cycles work, that's why the markets have long tried to decipher the cycles to be predictive, and there's an economic incentive. I heard somebody talk about magnetic therapy, putting magnets on the body. He said the people who got it the first were the horse trainers, the horse racers, because the horses need to recover. And because they're physical athletes, then they make their owners a lot of money when they win. And so they employed magnetic therapy to horses that get coddled and cared for, these race horses like you wouldn't believe.
Right.
And they'll use anything that works. They don't care about the theories. So
like NASA going to the moon.
Yeah. But this scholarship that you want to do, I think that one of your challenges would be to cook down what you have to say to make us and the lay audience more readily understand and follow along. And that's a big challenge. We don't have your math. We don't have your physics. You know, we didn't learn a lot of this in school to that degree. And so how can you bridge the gap between not everything that you have to add to your theories is going to be correct. Nobody's 100% correct. But if you have some basic truths that will emerge from this to open up our bandwidth and understand that we're far more influenced by this magical universe than we know, that we're far more influenced by these unseen cycles and energies and flux and flow than we know, then that's important. And that is part of this new knowledge base emerging.
Dewey wrote a paper late in his life called The Case for Cycles. In doing that, he first talked to Richard Feynman, who's perhaps was the most famous American physicist in that time. And Feynman said, under what circumstances you should accept this as a real cycle or affected by something else and all that. And he said, from that day to this, we obeyed all of his rules in the way we did our research. And he did. And so that was available on Cycles Research Institute website, The Case for Cycles by Edward Dewey. I recommend getting that. It's a summary of what had been found up till 1967. And I don't think there's no tricky maths in it. The most he does is to do moving averages of cycles, which is where you just take the bumps out and put a line down the middle. And so I would say that's a really good place for someone who wants to understand the essence of the problem. He once described himself as being like, I'm getting mixed up now, whether he was Tycho Brahe or whether he was Kepler. He was either Tycho waiting for Kepler or Kepler waiting for Newton. Whichever one he was, I want to claim to be the next one. So I've done that. Somebody else is supposed to say that, otherwise I'm being up myself. Anyway, so I'd say start there. I've got a lot of other material. I'll shoot you, you'll put this as a video, won't you? I'll shoot you some links, a bunch of links that people can go to do further research on a lot of these things.
Perfect, yeah.
And you call it Wobbly Universe. Do you want to go tell me why you chose that name? You started to describe the Jello model.
Yeah, that's right. It's all, it's doing that, yeah.
And wasn't Einstein saying something similar? He was saying that the space-time continuum can be misshapen.
Well, they're looking for gravitational waves, which would be wobbles in this thing, you know. And light and radio waves and all those things are wobbles in that medium, you know. So they, but what I'm doing is different to what the physicists do, is to say there is only that. Milo Wolf came to the conclusion it's only that. I believe that de Broglie came to that conclusion also, and I think probably Schrodinger as well. They believe that the waves were real. They disagree. Bohr won the argument with Einstein, but Einstein and de Broglie and Schrodinger were the ones that were right, because in some of those experiments they can't do statistics. A guy just got a Nobel Prize for doing the aspect, but a Nobel Prize for doing something, and the analysis is buggered up statistics. It's wrong. You can get the same results without believing the things he believes. It's classical physics. I believe, this is a subject for another talk, I believe the universe is Euclidean space and there is absolute time. Quite in contradiction to relativity, but you get the same equations as relativity. Nothing wrong with relativity's equations.
Yeah.
Okay, another question would be, you're talking really about a vibrational universe.
Yes.
And we've had these discussions before, we have such limited apparatus with our senses and our technology to open up the bandwidth to see the entire electromagnetic spectrum, right?
Yeah.
We're not detecting it all. That's what dark matter and dark energy are about. We know it's there. We know it has an effect. We just can't detect what that is. We can't see into it, right? We don't have a wide enough bandwidth to sense it.
Well,
So
you're absolutely right. Yeah.
so if what you're saying is true, that in the sea of energy that the universe is, the sea of vibration, there's a lot more layers to it than we're ever going to detect, right? So that there are mythic detection factors, mythic factor analysis. I interpreted that to say, I know that there are some factors impinging the whole. I just haven't found them yet. I know they're a myth until we find out what they are and can discern them.
You can experience more, and I possibly shouldn't tell you this for this reason.
Okay, with meditation, right?
Yes, meditation. Vipassana meditation develops your touch sensation, your feeling, so that you will experience a vastly wider range of frequencies. But that's not the right reason to do it. You ought to do it because it leads to total enlightenment. That's the objective. If you get off that objective, you will not get that objective, and that should be the objective.
Thank you. I appreciate that, and we have our own techniques for opening our bandwidth as well. So there's a beneficent universe offers many opportunities to do so.
It does.
It's sort of that intimate connection that we're displaying today through your analysis, but between ourselves and the cosmos. I mean, this has been part and a step of ritual that we honor the fact from the innermost part of ourselves to the unbounded universe, we are all connected. And this is also why throughout history, if you look to prehistory to today, traditional cultures understand the importance of cycles. And that's why they honor all of those steps through ritual. They used ritual as a foundation. And so
and why they were charting the equinox and the
things that we're dismissing as myth or whatever, they understood it's a science to them. It's their life, their livelihood, who they are.
I had an argument with a hard-nosed scientist who said, Western, you can't count Polynesian, Maori stuff as science. It's not. And I said, you were putting down the people who were sailing around the Pacific and hitting tiny little islands thousands of years before your ancestors could get across the Atlantic and hit a continent.
That's it.
Thank you.
You're right.
We have a talk with Steve.
I'm drawing a blank.
We had a talk with a gentleman who studied with one of those last remaining masters about navigating across the vast Pacific.
Right.
Stars, reading the waves of the water, the patterns of the waves in the water. Is it a land bird? Is it a seabird?
I think the National Geographic did a story about one of these guys. Yeah, they see radial lines and circular ones in the clouds and all sorts of things.
Yeah. If it wasn't a science, it's much of an art, and they do ritual as well, right? Yeah. They employ the weather gods to help them.
Steve Thomas. He was a host in the United States for This Old House, is what he's most known for. But Steve Thomas.
But as a young man, he went and studied with that. He was also a sailor. He's also a sailor. Yeah.
Well, you've done it, Ray. You've given us a lot. Incredible amount to digest and to connect the dots, and we just live off your enthusiasm for this, and hopefully we can have some further discussions to open the door.
Okay, and there is a further discussion that I would like to have with you and your colleagues, and that is, I wish to understand the ways that cycles have been found in astronomy. You touched on some of those. Biology, you touched on just the human body. Climate, I'd like to know more about the Milankovitch cycle. Cosmology, economics, you touched on the markets and the geology, history, physics, touched on that, sociology, war and weather. I mean, we didn't even scratch the surface.
Well, because cycles is everything. It's all of what life is. You can't really separate out the topic of cycles as some independent thing out there, because it's everything that we are.
But I would like to note the cycles that have been studied, because it's kind of fascinating to see. And the picture that emerges is that the universe is a grand clock. I mean, I hate that cold dead machine, right? But it is also a clock, and these things are gears upon gears upon gears upon gears.
Yeah.
How about
And I
killing?
think the Milankovitch cycle, we can have a specialist on in that,
Yeah.
but we really need to understand that we're supposed to be headed into an ice age driven
Yes,
by
that's right. Yeah.
the length of our orbit around the sun, the tilt of our planet. There are cycles that for the last 5 million years that we can track have pushed us into an ice age that lasts far longer than our interstitial warming period, our current period.
You're quite correct.
Yeah.
Quite correct. But there's one more thing to add to that.
Okay, I wanted to ask you.
There's a much longer cycle than that, which goes through what they call hothouse and cold house. In cold house, we're in a cold house, and the going in and out of ice ages exists in the cold house. But when you come out of that, you head up to the hothouse. Now, I suspect that this might have been that we might have had the last one of those ice age cycles. I don't know, I can't prove it, but if you look at the graphs of the long cycles, I've done talks on climate. If you go to my Wobbly Universe playlist on YouTube, you will find some of those talks, and you can see the graphs. And on a 300 million year cycle, we've gone from cold house to hot house to cold house to hot house to cold house, and it looks like we might be due to come out of that.
So we're coming out of the cold house where the ice age is predominant, the 100,000 year ice age versus the 14,000 year interstitial. And we're going into a hot house. And that probably is not going to bode well for
it takes 100 million years to get up there.
And there was snowball Earth, right? The cold house, I mean, its max would be snowball Earth, or was that an anomaly? The ice ages are the depths of the cold that it gets in those. What we're in the moment isn't the hot period, it's just a fraction of the way up. And so I think on the long-term scale, all mammals developed in a period when the Earth was much warmer than it is now. And I want to disagree with them about that. I've got a whole talk about climate that you can see on my YouTube. Bobby Universe. But I think that they've got all these things wrong. They think CO2 is causing temperature change. I think it's the other way around, and I've got data that proves it. What's more, human activity is greater now, and I think it's because the Earth is warmer that human activity is picked up. If you heat up insects, they run around a lot faster, and it's the same with humans. And if you go near the equator, people get about more than they do at the poles. And there's a lot more life at the equator than the poles. And I think that warming is not, it may flood a couple of places, but it's actually, more people die of cold than die of heat. And it's actually good for the world. And more CO2 makes plants grow faster. So I'm going against all the conventional wisdom there, but I've got data that proves I'm right and they can't answer it.
Yeah. Wow.
Sharon says comet orbit cycles would be interesting to throw into the planetary phenomenon. Diane is thanking you and says a lot to digest.
Right.
I'd like to hear some thank yous. I mean, this was a controversial picture. I want to hear from you. Did you enjoy today? And what do you want to say to Ray? I actually appreciate people who step outside the bounds of known knowledge because we don't know everything.
Yes, no, I just want to say thank you. This is, a lot more than what I was expecting.
Me too. Me too.
Me too.
Me too.
It always is.
Thank you, Diane.
I appreciate that. Yeah.
Thank you for coming.
Yeah. Very cool. All right, Ray.
Well,
have a good day.
You too. See you later.
All right. Peace,
Thank you, guys.
everybody. Take care of yourselves, and we'll see you next time.
Thanks for hanging in with us to explore some new thoughts.